Alright, we have regression. So I'll show you how to do regression, quadratic, linear, and exponential in Desmos. Now, I don't believe regression will directly be tested on. Like, they're not going to ask you, do you know how to do regression? But it's going to be a super useful shortcut when you're trying to find the y-intercept or the slope. So let's get started. For linear regression, I'm really sorry about the quality. My goodness, that's horrendous, but hopefully it's still readable. So your standard form for a linear function is going to be y equals mx plus b. Now what you're going to put into Desmos is going to be a little bit different. You're going to put in y1 tilde mx1 plus b. So all we did is we added a 1 to the y and the x, and then we changed that equal sign to a tilde. And for regression, you're going to need 2 points. Now you're going to see what I mean by this in just a bit. Okay, I have Desmos open, and this is the SAT version. So I'll put the link to this in the description, or you can really just search up SAT Desmos. Now it's going to be really important that you use this specific version, because this is going to be the exact same one you'll see on the test. Now the first thing we want to do when we're doing regression is put in a table. So we're going to look at this plus icon right here. We're going to click on that and go to table. And you can see you have a table right here with x1 and y1. So of course in x1 we're going to put in our x values, and y1 we're going to put in our y values. I'm going to just make up some random points. So I'm going to do 0 and 4 and then 2 and 6. Sure, why not? And if you want to go from like left to right, you click the tab button, and if you want to go up and down, you click the up and down arrow keys. Now that we have our points in, we're going to use that regression formula that I just gave you, which is going to be y1 tilde mx1 plus b. Now when you type in the ones, it like instantly makes it go subscript like that, so you don't need to worry. And now that we have this table in, we have the table and the regression formula in, it gives you the slope and it gives you the y-intercept. So just like that. And as you can see, you only need 2 points. Alright, you need at least 2 points. You can put in as many points as you want, but you need at least 2 points for this regression formula to work. One more thing I want to quickly point out is that the reason we use y1 and x1 here is so it matches with our table up here, which is x1 and y1. Now if we just did not delete this table and we added a new table, then you're going to see we're going to use it's going to use x2 and y2. So in your next equation you would have to use y2 tilde mx2 plus b. So whenever you're doing these equations, just make sure that your equation matches up with the table. Or if you want to make it easy, just always delete your tables after you're done with them, and then it will reset back at 1. For quadratic regression, we have the standard form of a quadratic, which is y equals ax squared plus bx plus c, and just like the linear regression one, our quadratic regression formula is going to be y1 tilde ax1 squared plus bx1 plus c. So all we're doing is adding 1s to the y and the x's. In this one, we have 2 x1s because the standard form has 2 x's. And for quadratic regression, in our table, we're going to need at least 3 points. Here's Desmos. First thing we're going to do for any regression equation is put in our table. And then for quadratic, we need at least 3 points. So I'm going to do 1 and 4, 2 and 6, and 3 and 4. And if you remember, a quadratic is a parabola, so it's symmetrical, which means every point from the vertex will have the same y values. Well, I won't say every point, but you know what I mean. Then we're going to put in our regression equation, which is y1 tilde ax1, and to do the square, you're going to look at the number 6 on your keyboard, and you're going to press shift and 6. And that should be the arrow key, and then just type a 2 plus bx 1 plus c. Then there we go, we have our graph right here, and then we have all of our parameters, our y-intercepts, and whatever. Lastly, we have exponential regression. So the standard form of an exponential equation is y equals ab to the power of x, and just like with the rest, our regression equation will be y1 tilde ab to the power of x1. So once again, we're just adding 1s to the y's and the x's and changing the equal sign to a tilde. And for the table in an exponential regression formula, we're going to need at least 2 points. Here's Desmos. First thing we gotta do is put in our table. There we go. Then we need at least 2 points, so I'm gonna do 1 and 2, and 3 and 8. Then we put in our regression equation, which is y1 tilde ab to the power of x1. And there we go. We have our parameters now, we have our exponential equation, and I haven't been doing this with the rest, but you can just go ahead and substitute it in. So y equals a is 1, so 1, b is 2, times 2 to the power of x, and as you can see, these two are the exact same line.